Video problem 77, equilibrium in saturated solutions. Lead 2 iodide is a slightly soluble salt. In a saturated solution, the concentration of lead 2 plus is 1.29 times 10 to the negative third molar. Determine the KSP of lead 2 iodide. First, let's write out the KSP of lead 2 iodide. It looks like this. Here's the equilibrium expression. Okay. And again, these are concentrations, so those are equilibrium concentrations. And I know one of them. I know that lead is 1.29 times 10 to the negative third molar. Well, I know the iodine as well, because these two are in a stoichiometric ratio. So I'm going to do times 2 to get the concentration of iodide, which is going to be 2.58 times 10 to the negative third. Okay, so if I know the lead, I know the iodide. If I know the iodide, I know the lead. So I can just plug those values in and crank out a KSP. Don't forget to bring down your 2 here, alright? Get my handy dandy calculator. And I get a value of 8.59 times 10 to the negative 9th. Okay, so pretty small number, but it should be small because I'm talking about some pretty small molarities here. Alright, so remember, if you know one of the concentrations of the ions, you know the other one. Alright? Alright, if the molar solubility of calcium fluoride at 35 degrees Celsius is 1.24 times 10 to the negative third molar, what is the KSP at this temperature? So, again, I'm looking for KSP. This is going to be, let's write out the dissociation reaction. It's calcium fluoride, solid, is in equilibrium with calcium 2 plus 2 fluorides. Okay, so that means it's calcium 2 plus times concentration of fluoride squared. Now they've given me what's called the molar solubility of calcium fluoride here. The molar solubility is how many moles are actually dissolved in 1 liter. So I can say that this value is 1.24 times 10 to the negative third, and that's the amount that actually dissolved, not the amount of solid, but the amount that's actually dissolved. So that means that I can use this and say that this is also 1.24 times 10 to the negative third, and that this is 2.48 times 10 to the negative third, which is 2 times that value. Again, let me reiterate, this is not the amount of solid that we have. This value is the amount of that solid that actually dissolved, and when it does dissolve, it dissociates completely. Okay? So again, I'm just going to calculate KSP. I don't know why I'm writing that again, but I did, so there. Alright. I get a value of, for my KSP, 7.63 times 10 to the negative 9th. No units because it's KSP.